Hello freebie. So in this video I want to talk about the example of using perfect square to do factorization. Alright, so for this case actually we have two identities to do factorization with this type of question. First of all, the equation will be something like this. Okay, sorry, it should be a plus. Alright, and we know that if we factorize these types of expression, it will become a plus b squared. And the second identity is minus 2a in the middle. Okay, so this is the first one, second one. Okay, and for this it should be a minus b squared. And we always emphasize the sign. So you can see that in front of a square, it always a plus. In front of a square, it's always a plus. And in front of b square, it's also always a plus. Okay, that means once you want to try to use this identity, all the terms with square must be a positive terms. Okay, so let's take an example. Let's say question A, x squared plus ax plus 16. So first of all, we can see that x squared is a square term. 16 is also a square term because we can make it becomes 4 to the power 2. Okay, so the 16 is also a 4 to the power 2. And also you can see that all these two terms has a positive in front of it. Okay, so we think that it may be able to use identities to solve it. And then the next is x squared, and the last is 4 squared. So in the middle, it must be 2ab, 2 times ab. So it is a positive, right? Okay, so we put the positive here. And then the 8 we can divide as 2 times x times 2. Okay, so sorry, 2 times x times 4. Okay, because 2 times x times 4 is a plus, right? Then 2 times 4 is 8, right? So it is a positive 8x, that's what we want. Alright? And we can see that the x is the same as a, and the b, the 4 is the same as the b. Okay? So it is a possible expression that we can directly make it to x plus 4 to the power 2. Alright? So let's do one more example. Let's say question C, m squared minus 18mn plus 81n squared. Okay, so we can see the first term positive, the last term positive, and both of them can be written as a square. Okay, remember to give a bracket here. Okay, and in the middle it is a minus. Okay, and then it must be a 2 times something. Okay, and then we can make it as 2 times m times 9n, because 9 times 2 is 18, right? And the m match the first term, 9n match the last term. So it is m minus 9n squared. The minus come from the blue minus. Okay. Okay, so you may try the other two yourself. Okay, let's go on. Okay, now let's start this question. So for this question, first of all, I will suggest you don't try to use the identity at the very beginning. Actually, you can see here the first term, you cannot find any square of them. Okay, and also the second term or the third term, all of them cannot be squared. Okay, so actually we cannot use the identities to directly factorize this question. So we may go back to very basic techniques. Okay, we should try to take out common factor of the question, because you can see the 3, the 75, and also the 30, they should have common factor 3. Okay, so we should try to take out common factor 3 from all term. Okay, so the answer should be 3x squared plus 25y squared minus 10xy, right? Okay, and to this stage, x is a square term because x to the square, and the second term, it is a square term. It is a 5y whole bracket square, but the last term is not squared, cannot be squared. Okay, so actually we should rearrange the polynomial such that the first and the last are the square terms. Alright? And then let's do a checking. The first term is x squared. The last term is 5y. So if we try to find x 2 times x times 5y, it is positive 10y. Sorry, 10xy. Right? Okay, so actually for the value, it is what we want. Okay, but surely it is not a positive, it is a minus, okay, negative 10xy. Okay, so by using the identity, we can just directly move the whole yellow parts into its factorized status, x minus 5y squared. Okay, so this is the answer already. Let's go on. So how about this question? So it seems quite complicated, right? But we can try to make it simple by taking let's say we give a big letter A to represent 2A plus B. Then you may think that this is more easy to understand. Okay, substitute. Okay, a big A to 2A plus B. So it will become 9 plus 6A plus A squared. Okay, and you can see that it is quite easy to understand because 9 is square of 3 and A squared is A3. So we try to test it. 3 and A, we combine to 2 times 3 times A. So this is 6A, right? And this is positive. So that is what we want. Alright, so we can just write it as 3 plus A squared. Okay, and lastly, we put back A to 2 small letter A plus small letter B. So the equation will become 3 plus, remember to give it a bracket, okay, and then we break the bracket and see any like term inside. Okay, but no like term, then this is the final answer. Okay, now let's take a look for this question. Okay, so for this question, you can see here we have 1, 2, 3, 4, 4 terms. Okay, 4 terms. So, and we don't have any common, so first of all, there are 4 terms. Right? And so maybe we should use grouping term to solve it. Right? So how to group it? Okay? Maybe you can try. Okay, first of all, maybe we can try it 2 by 2. Okay? Let's say 9 minus 4y squared, and then minus 12yz minus 9z squared. Okay? And then we try to factorize the first part. Okay, it may become 3 minus 2y, 3 plus 2y. And the second part, we take out the negative 3z. So this is 4y plus 3c. Okay? However, you can see we cannot create any like term, any common factor in the x polynomial. Okay, so the way we group it 2 by 2 cannot be used to do factorization. Okay, so fail to group 2 by 2. Okay, sure, you can try to group other combination. Let's say this and this. Right? Okay, you can try. Also, you can try. Okay, but we just try to not using this grouping method. All right. Actually, it seems okay. You can try. Okay. All right. If 2 by 2 cannot be used, then we may try to use 1 by 3. 1 by 3. So how to do it? You may try this. You may be able to factorize. Okay. Okay. So if we want to use a 3 by 1 method to factorize, that means we should have something like this or something like this. Right? And in this polynomial, actually the most possible way to factorize it is maybe this is the first term, the a squared term. This is the b squared terms. Okay? However, in front of them, there is a minus. Right? Okay, so it seems it cannot be factorized like this. However, we can try to consider like this because we want to factorize 1 by 3 terms. Okay, and these 3 terms seems to be the most possible way to factorize. Then we can try to take out common factor from all the terms, but we only can take out the negative side of all the terms. Okay, and once again, you see here it is a 2y squared term, and here it is a 3c squared terms, and we try to test it. 2y, 3c, we combine them, 2 times 2y times 3c. This is 2, 2, 4, 4 times 3, this is 12. Okay, and we put it positive. Okay, so that we want. Okay, can you see in the middle? Okay, so actually we can factorize it to 2y plus 3c squared. Alright? And then for this form, it becomes 3 squared. And here we have 2y minus plus 3c squared. Okay, we can further factorize it to 3 minus 2y plus 3c, remember the bracket, and also 3 plus 2y plus 3c. okay, and then we simplify it. It becomes 3 minus 2y minus 3c, 3 plus 2y plus 3c. Okay. So actually, for solving this type of equation, we will have many methods to do the factorization. Okay. So actually, you should try. Okay. At the very beginning, we try to group it 2 by 2, but it seems failed. Okay. And then we try to group it 1 and 3. Okay. Maybe you can try the first 3 terms. Okay. And then we try until we find the final way to factorize this type of equation. Okay? So that's the end of this video. Okay? See you